www.reslibrary.com.
Hi everybody, first of all, share with you. Today we are going to talk about R.E.D.S library, and this is my presentation in IIUM University. What is the reason for R.E.D.S library software? Why we should use R.E.D.S? R.E.D.S library phases R.E.D.S, solar desalination systems, wind desalination systems, and geothermal desalination. Some examples, or what is the validity, website, and how can we run our model, how can we download, scientific research cooperation that we can cooperate with, and some useful links to deal with. First of all, R.E.D.S library is it's a modeling library that enables users or designer to model and simulate renewable desalination systems, solar, wind, geothermal, or even hydropower, conventional power. All of such energy resources are constructed in a library beside different desalination processes, with same link MATLAB code can be used. It has some features: easy model construction, user can drag and drop his units, they connect and run, easy to reform or your model, even it's fully editable, easy to convert your design model in different computer languages such as Visual C++ or Visual Basic. The model allows users easily to change the plant variables and different operating conditions, dynamic mode, transit mode, fixed point mode, and so on. Why R.E.D.S software package? Because we encountered a very important question, and we have to give a decisive answer about it. The question is, what is the cost of 1 meter cube per day of fresh water by the use of conventional desalination plants? Okay, what is the cost of 1 meter cube per day of fresh water by the use of renewable desalination plants? And what is the design limits of such desired plants? Or suppose I found a specific design for something. What is the design limits? What is the best operating conditions? And how can we tackle modeling complications beyond such configuration that we're going to deal with? It's completely quite interesting to answer such question, because if you are going to answer what is the cost of 1 meter cube per day of fresh water, you have to give me the design limits, which type, which configuration, and so on. The desalination process, it's quite hard to answer, because we have for the desalination process itself, we have different types: multi-phase, MEDE, vapor compression, silver compression, smooth, different configuration for each type. We have for renewable power cycles the same problem: different types, different working fluids, different configurations, solar tower, parabolic trough, many parameters. For the desalination part, we have different techniques and configuration for each type. For example, as you can see here, for multi-phase we have 3 types: brine recycle, one-through brine mixing. For MED we have parallel feed, backward feed, forward feed with feed heaters. Number of effects is a key rule for such configurations. We have multi-effect evaporation, mechanical vapor compression, the same problem: thermal vapor compression, reverse osmosis with energy recovery device, without energy recovery device, single stage, 2-stage, permeate cycle. It's quite, for example, this is multi-phase brine cycle. As you can see here, it's too complicated because we have forward streams and backward streams. it's quite hard. We are not going to go in deep explanation for this. We just would like to demonstrate that such a process contains many of forward and backward streams, which it is hard to be tackled and it's hard to be modeled. The same for MED forward feed heater, different configuration. I'm asking the user or the designer which configuration you are going to use. This is MED parallel feed configuration, mechanical vapor compression. That's correct. We have outputs and input streams, and we have also embedded streams you have to deal with and to discover the values or calculation values related to it. This thermal vapor compression, as you can see here, very complicated. So for each configuration we have interactive units and streams, we have forward and cycle streams. Suppose I'm going to discover the output stream, the input stream to the turbine unit. It's number one. You have to assign this or to calculate this. If you are going to calculate this, you have to calculate the stream number 6. At the same time, you have to calculate the stream number 2, because number 2 is responsible, by the way, in directly way for stream number 6 and number 8. It's two complicated methods. We have to seek a reliable modeling technique in order to discover the calculation methods or the values or the analysis of each streams. In order to perform reliable analysis of this wide range of power cycles and desalination processes under different operating conditions, different design parameters, different working fluids, a flexible and reliable computer package is required. That's our target in order to answer the first questions: what is the cost of 1 meter cube per day of distilled water? As such package should be or should have some features, should have some features such as generality, flexibility, friendly interface, executable, reliability, and accuracy, or provide design or performance. You have to answer such question. For performance, performance is a different matter from design. If you are going to measure the efficiency of something, but it's existed, already existed, so you are dealing with performance matter, because internal streams and variable output streams are still unknown, and for feed stream variables and design parameters is kept known for such technique of modeling. For design model, that's what we are dealing with. You have to measure the design aspects based on the recognition of efficiency. Some of output stream should be known, and some of design parameter and all feed variables are kept unknown for such technique of modeling. We have simulation program, we have special purpose program, sequential matching technique, simultaneous matching technique, and we have general purpose, sequential and simultaneous also. For special purpose, we have it's little bit rigid structure, simple and straightforward. It's fixed configuration, and changes requires extensive reprogramming, such as if you are going to build your model based on M files or text files or something like this, you have to rebuild your program in order to make some information or some editing to your program. For general purpose, it's can be applied for different processes with different configurations, with different working fluids, and different flexible in general. You can remove some units and add some units with ultimate stream allowance, and that we are going to use. That's the reason for us to use MATLAB Simulink, because it's ultimate unlimited stream allowance. We need to convert the real complicated plant. This is a real plant, for example, multi-stage flash. This multi-stage flash, segment by segment. We have to convert such configuration, and this is a schematic, into a code, and by this code we are going to convert it as the blocks, and for the blocks we can connect and remove and edit and do what we are going to do. Let's library phases. We have to pass through some phases. Phase 1, it's about data collection, choosing Simulink model, draw your plant. Suppose I'm going to this solar feed pool heat exchanger pump, just a schematic plant, and use your calculation methods, build your edit blocks, and you can collect between each blocks, and reforming by this a whole plant. This is the ordinary marching technique. As you can see here, we transformed this into such technique by Simulink. As you can see here, this is the whole plant: solar field, turbine unit, reverse osmosis, evaporator, condenser, pumps, and so on. And we can drive out our results. As you can see here, validity. This is phase 3. Phase 3 is responsible about, or talking about the visual interactive, that we are going to add interactives and interactive units and visual aspects. Here you can draw out your results. By the same phase sequence, we created 3 main libraries. Solar desalination systems. It contains desalination units, heat exchangers, solar collectors, solar plants, solar radiation models, and so on. And we have wind turbine units. And for wind turbine is for horizontal axe wind turbine and vertical axe wind turbines. And we have geothermal desalination energy. Of course, we have dry saturated plant, we have flashing plant, we have binary cycle plant. We can run some models. We have a lot of models as an example, as you can see, and we can run one of them. Okay, as you can see here, suppose we are going to run geothermal single flash steam for multi-effect distillation, simple vapor compression. This is a stream coming from the geothermal. We have a flash tank for steam flashing. This is a motive steam for steam ejector, and this is indirect steam, and this is a motive steam. This is a steam driving the first effect, and the condensate should be accumulated into the accumulation tank and repump it again to the geothermal field. We can select we can assign some inputs. This is suppose I'm going for 1,500 meter cube per day, ambient temperature 25. That's quite interesting. Okay, let's go and see our plant containing single flash. This is single flash. We can assign some inputs such as steam velocity. Okay, and this is geothermal well. Steam pipe diameter, suppose it's 7-inch diameter, and we have pumping unit, and we have this is power generated. Goes to power generation from the public grid in order to power on bombs of MED semi-vapor cooperation. You can assign some seawater temperature or sand water temperature, salinity profile. Suppose this is seawater salinity. Suppose it's around 35,000 ppm, and this is our target because it's a design model. Our target it's 60,000 ppm, and this is prime blue down. This is prime blue down temperature out from the prime from the blast effect of the MED. And we can for design ejector we can assign ejector compression ratio. Suppose it's around 2. We can change this dynamically. And this is motive steam pressure. Condensed number of effects, we can assign some number of effects. Suppose it's 6 effects. Let's go for high performance. And we can assign efficiencies because this is a design model, and some cost analysis we can assign. Okay, that's it. Save. We can set our time into infinity here, and we can see the effect of some parameters such as productivity or motive steam. Let's go for motive steam and see the effect of MEDs. This is MED semi-vapor compression model. This is bombs, MED profiles, and this is steam ejector. And we have to keep watching steam saturation temperature. Let's go and run our model. Let's hit run and make some changes. Okay, as you can see, there's some results for this is to let's go for steam ejector and trying to increase the motive steam temperature. As you can see here, increasing the motive steam temperature to higher values. Let's keep changing. Trying to change motive steam 2006 3000 kilopascal. Okay, 4000. Okay, that's increasing and decreasing motive steam. You can also increase controlling the pressure ratio, total steam pressure over entrained pressure, entrained steam pressure. I'll keep down below to 2, a value of 2, down to 2500. Okay, that's it. Stop. And we can see our results. As you can see here, that's our results. Let's see some fluctuation, and this is in the condenser cooling water flow rate. Suppose let's adjust the format. Okay, up to 100. Okay, the fluctuation you based on changing motive steam flow rate. We can see here some this flash tank volume, and flash tank width and height. Okay, well temperature. This well temperature upside down because the demanded steam from the geothermal well is high. We're talking about we need 450 degrees Celsius down to 300 degrees Celsius. This is silica concentration in the well. This well depth fluctuating according to the demanded steam. Okay, that's validity. We succeeded to publish many of our publication and in international journals with impact factor, such as Wind Energy Journal, and we have in Desalination Journal. We have a paper about R.E.D.S package, and we have R.E.D.S package in Water and Treatment Journal, Applied Energy This model is too impressive, is very impressive model, because it's about utilizing waste gases from oil refinery. Instead of burning it, we are going to use it for binary desalination between MED and multi-stage flash through the flash tank. And we have in renewable energy journal, desalination, again, desalination and water treatment, energy conversion and management, asthma journal, energy, this is asthma journal, again, desalination, and so on. We participated in many international projects, such as PASO project, FB6, massive project in FB7, PowerSub project, Egypt, STDF, R.E.D.S project, Alexandria. You can visit our website. Let's go and see if we are going to use our website for download and something like this. Okay, clicking on our link. Okay, as you can see, this is our website. It's library, as you can see here. There's useful links if you are going to follow us with on Twitter, our YouTube channel, as you can see here. This is our YouTube channel. As this is our tutorials videos. This is our tutorials, as you can see here. Sure, would increase this is a flash cycle. Okay, and this is our research gate, LinkedIn, Facebook. You can visit our page on Facebook, as you can see here. This is our R.E.D.S library. You can go for shopping, for posts, follow. You can follow us easily and do what you would like. It's very good for communication. And this is our flyer. Our flyer is just a demonstration about our work, our softwares. You can take a close look about our activities and our new products, new models, and so on. Okay, you can go. This is our scientific. This is our publications. You can download easily our publications, thesis, many of useful things you can do here. Services. Okay, this is you can for community and communication. You can. It's better to subscribe just by write your email here, in order to we can able to be or capable of following you. This is tutorials. You can download some tutorials, see some tutorials. This is videos, some flyers, and so on. You can go for shopping. This is let's shop, and here you can select your model. It's easily you can select. We have many categories. We have auxiliaries for thermal units, desalination, geothermal, SDS, WDS. Suppose I'm going for desalination units. I'm going for, suppose I need to download MED parallel feed, for example. Okay, I'm sorry. Yes, all you have to do is to read something about it. Okay, you can watch the video link. You can share. You can follow. You can just click add to cart. When you add to cart, you have to watch this. This is your cart. You can click here, or by continue serving, you can add many of our products, and you just go to view your cart, and from here you can check your PayPal. Checking your PayPal. If you don't have PayPal account, you can also go here. Okay. You have two options. If you have PayPal account or pay with online banking, you can pay with online banking. Okay, you can choose easily your country. Okay, you can enter card number, CVV, and first name, some inputs. It's easy, so easy, and you can click continue, and you will get your model automatically after completing the payment. Okay, for scientific cooperation, we're looking for new work with photovoltaic, horizontal wind turbine with fuel cell or hydraulic power, or natural gas extraction for thermal power and water production. We are going to continue building our GDS library. This is a new model. It's about natural gas extraction through gas compressor. It will generate more heat waste, and we can utilize this for desalination. It's quite interesting. This is our useful links, lesabel.com, our YouTube channel. You can communicate with us. Finally, thank you for watching. Don't forget to like, share, subscribe. Thank you very much.